Okay, so this is Chapter 11, Lesson 3, Calculating Relative Error. Your objective is to calculate the relative error in measuring square and cubic units. So the big question is what is relative error? Relative error is another way to describe the extent of error. And percent of error is one way to describe how accurate a measurement is. Both of these things you need to know. So I'm going to give you a very real scenario. This is a true story, so it's part of history, and he's a scientist. I'm just going to give you background. Enrico Fermi, he was an Italian physicist. He was best known for his contributions to the development of quantum theory and nuclear and particle physics and statistical mechanics. So this guy was very smart. And just so you all know what he looks like, that's what he looks like. Italian physicist Enrico Fermi came up with a simple way to estimate Earth's circumference. And circumference is around the Earth. So Fermi reasoned as follows. It is about 3,000 miles from New York to Los Angeles. There are 4 time zones in the continental United States, but you only cross through 3 of them when traveling from coast to coast. This means that each one of the 24 time zones must be about 1,000 miles wide. Therefore, the approximate measure of the Earth's circumference is 24 times 1,000, or 24,000 miles. If the actual circumference at the equator is about 24,902 miles, how accurate was Fermi's measure? To find how accurate Fermi's measure was, find the percent of error and relative error. And again, I know I'm saying Enrico right. I'm not sure if I'm saying Fermi right. But we need to find the percent of error and relative error. So what Fermi thinks the approximate measure of the Earth's circumference. So he says it's 24,000 miles. 24,000 miles. So we have the absolute value of 24,000 miles minus, the measured value of 24,000 miles minus the actual value, which is actually about 24,902 miles. This is also the end of the absolute value, divided by, and I'm keeping this red because I'm doing my actual value, 24,902 miles, times 100. So 24,000 minus 24,902 all over 24,902 times 100. If you type this in your handy dandy calculator that you're able to use, you should get 3 6/10%. You need to round to the nearest tenth. And to convert this to relative error, so this is my percent of error. It's a percent, so that's kind of obvious. To convert this to relative error, I need to convert this to a decimal. And how do you convert a percent to a decimal? You should have said divide it by 100, or you should have said move your decimal 2 times to the left. Both of those are the same thing. That's what you're doing. So I'm moving my decimal 2 times to the left, and you can't see what I did because my face is in the way. So I moved it 2 times to the left, and I got 36 thousandths. That is my relative error. I'm going to put RE because I'm going to run out of room writing with the stylus. Pretty easy? Okay, so I put it on this slide as well. Your percent of error is one way to describe how accurate a measurement is. The relative error is another way to describe the extent of error. So here's your equation. The percent of error equals the absolute value of measured value minus actual value all over actual value times 100. The relative error is the percent of error written as a decimal. So basically, once you get the percent of error, you can get the relative error, and once you get the relative error, you can get the percent of error. So here's something to note. You are finding the absolute value of the measured value minus actual value. When calculating a percent of error, It is the size of the error that is important, not whether the measured value is greater or less than the actual. That is why it is absolute value, because absolute value is always positive. So let's go ahead and work this. I'm sure you're tired of me talking already. So our measured value is a store owner measured a shipping box and advertised its dimensions 30 inches by 24 inches by 14 inches. The actual dimensions of the box were 29.5 inches by 23.5 inches by 13.5 inches. What was the percent of error and the relative error of the store's owner's measurement in terms of the box's volume? So before you do anything, you are going to have to find the volume of a box. Well, the volume of everything is the volume equals big B, and remember what big B stands for. Big B stands for the area of your base times your height. Lucky enough for you, this is a shipping box, which means it's a rectangular prism, which means you can just do length times width times height, because that's essentially what you're doing. So you can multiply all of the dimensions, and that's how you'll get the volume. So, because volume is three-dimensional, so we have a store owner measured. This is the measurement that he got, which is this right here, which means that this is the measured value. So you have to do the volume equals 30 times 24 times 14, and this is the measured value. And then you have to find the volume of the actual value. Volume would be 29.5, the actual dimensions. So what's going to really hurt some of you is y'all don't want to read, and that's really going to hurt you. 23.5 times 13.5. And this would be your actual value. So I have given you only one example, but I honestly believe that that one example can really help you. Instead of making this video even longer, I want you to solve this problem. Now that I've gotten you started on it, you should, I put view. Now that you have gotten it, I want you to work it out. And tomorrow when you come into class, we will check this problem.